The question at hand involves the proper interpretation of the National Electrical Code, specifically Section 230.7, regarding service entrance conductors and whether a 4/0 shielded electrical cable run from an outdoor fuse disconnector main lug panel inside a home requires conduit protection. The inspector's argument is that the wiring inside the home constitutes part of the service entrance and, therefore, must be enclosed in conduit, as mandated by National Electrical Code Section 230.7. The counter-argument is that the wiring in question is not service entrance wiring, but rather a branch feeder that is fused for overcurrent protection, negating the necessity for conduit protection. To resolve this discrepancy, it is crucial to delve into the definitions provided by the National Electrical Code and analyze the specific circumstances of the installation. According to National Electrical Code Article 100, service entrance wiring encompasses the conductors and equipment responsible for delivering energy from the serving utility to the wiring system of the premises served. Conversely, a branch feeder is defined as a conductor, or a group of conductors, that carries current from a panel board to the points of utilization within an individual building. National Electrical Code Section 230.7 stipulates that service entrance conductors must be installed in raceways, such as conduit, when installed as open conductors or when passing through holes in walls, ceilings, or floors. Based on these definitions, the wiring extending from the fuse disconnect outside the home to the main lug panel inside the mechanical room is best categorized as a branch feeder, not service entrance wiring. Consequently, the conduit protection requirements outlined in National Electrical Code Section 230.7 do not apply in this scenario. Several additional considerations further support this conclusion. Firstly, the fuse disconnect located outside the home provides overcurrent protection for the branch feeder, mitigating the risk of damage from excessive current flow. Secondly, the 4/0 shielded electrical cable possesses an ampacity rating that surpasses the load requirements of the branch feeder, ensuring that the wiring can safely handle the anticipated current. Thirdly, the wiring installation adheres to the requirements stipulated in National Electrical Code Chapter 3, which governs branch circuits and feeders, providing a comprehensive framework for safe and reliable electrical distribution. In conclusion, based on the National Electrical Code definitions and the specific circumstances of this installation, the assessment that conduit protection is not required for the branch feeder wiring running from the fuse disconnect to the main lug panel is the correct one. The inspector's interpretation of National Electrical Code Section 230.7 appears to be misapplied in this particular instance. To further elaborate on the nuances of this situation, let's consider the path of electrical current from the utility source to the various loads within the home. The service entrance conductors, originating from the utility transformer, terminate at the service disconnect, typically located at the meter. From this point onward, the wiring transitions into the distribution system within the home. In this specific case, the installation incorporates a fuse disconnect located outside the home, adjacent to the meter. This fuse disconnect serves as the point of demarcation between the service entrance and the branch feeder. The conductors extending from the fuse disconnect to the main lug panel inside the mechanical room are responsible for distributing power to the various branch circuits that feed individual loads throughout the house. These conductors function as a branch feeder, rather than service entrance conductors. The purpose of National Electrical Code Section 230.7 is to ensure the protection of service entrance conductors from physical damage, particularly in situations where they are exposed or penetrate building structures. However, in this scenario, the branch feeder conductors are already protected by the upstream fuse disconnect, which provides overcurrent protection. Furthermore, the shielded electrical cable offers a degree of physical protection, reducing the risk of damage from external factors. The National Electrical Code provides specific guidelines for the installation of branch circuits and feeders in Chapter 3, as previously mentioned. These guidelines address various aspects of wiring, including conductor sizing, overcurrent protection, and wiring methods. Compliance with these requirements ensures that the branch feeder is installed in a safe and reliable manner. It is important to note that the interpretation of the National Electrical Code can sometimes be subjective, and inspectors may hold differing opinions. However, in cases where there is a disagreement, it is essential to consult the relevant code sections and definitions, and to consider the specific circumstances of the installation. In this particular case, a careful analysis of the code definitions and the installation details supports the conclusion that the wiring from the fuse disconnect to the main lug panel is a branch feeder, not service entrance wiring. Therefore, conduit protection is not required under National Electrical Code Section 230.7. It is also important to note that the use of a fuse disconnect outside the home provides an additional layer of safety and protection. This disconnect allows for the isolation of the entire branch feeder in the event of a fault or emergency. It also provides a convenient means of disconnecting power to the home for maintenance or repair purposes. The selection of the appropriate size and type of overcurrent protection for the branch feeder is critical to ensuring its safe operation. The overcurrent protection device, such as a fuse or circuit breaker, must be sized to protect the conductors from overloads and short circuits. The National Electrical Code provides specific guidelines for the selection of overcurrent protection devices based on the ampacity of the conductors and the type of load being served. In addition to overcurrent protection, it is also important to consider the grounding and bonding requirements for the branch feeder. Grounding and bonding help to ensure that the electrical system is properly grounded, reducing the risk of electric shock and fire hazards. The National Electrical Code provides specific guidelines for grounding and bonding, which must be followed to ensure a safe and reliable installation. In summary, the wiring from the fuse disconnect outside the home to the main lug panel inside the mechanical room is a branch feeder, not service entrance wiring. Conduit protection is not required under National Electrical Code Section 230.7. The fuse disconnect provides overcurrent protection for the branch feeder, and the shielded electrical cable offers a degree of physical protection. The installation must comply with the requirements of National Electrical Code Chapter 3, including conductor sizing, overcurrent protection, and grounding and bonding. It is also crucial to consider that local amendments to the National Electrical Code may exist. These amendments adopted by local jurisdictions can modify or supplement the requirements of the National Electrical Code. Therefore, it is always essential to consult with the local electrical inspector to ensure compliance with all applicable codes and regulations. Furthermore, it is advisable to maintain clear communication and documentation throughout the electrical installation process. This includes providing the electrical inspector with detailed drawings and specifications, as well as documenting any deviations from the code requirements. Proper communication and documentation can help to avoid misunderstandings and ensure a smooth inspection process. The concept of service entrance versus feeder conductors is a foundational aspect of electrical system design and installation. A clear understanding of these distinctions is essential for ensuring compliance with the National Electrical Code and for providing a safe and reliable electrical system. Service entrance conductors, as previously mentioned, are the conductors that bring power from the utility to the premises. These conductors are typically larger in size and are subject to stricter installation requirements due to their higher voltage and current carrying capacity. Feeder conductors, on the other hand, distribute power from the service entrance to various sub-panels or loads throughout the building. Feeder conductors are typically smaller in size than service entrance conductors and are subject to different installation requirements. The National Electrical Code provides specific guidelines for the sizing and protection of both service entrance and feeder conductors. These guidelines take into account factors such as the load requirements, the conductor material, and the ambient temperature. Proper sizing and protection of conductors is essential for preventing overheating, voltage drop, and other electrical hazards. In addition to the distinction between service entrance and feeder conductors, it is also important to understand the different types of wiring methods that are permitted by the National Electrical Code. Wiring methods refer to the way in which conductors are installed and supported. Common wiring methods include conduit, cable, and open wiring. Each wiring method has its own advantages and disadvantages, and the selection of the appropriate wiring method depends on factors such as the environment, the application, and the code requirements. The National Electrical Code provides specific guidelines for the installation of each wiring method. These guidelines address issues such as support spacing, protection from physical damage, and grounding and bonding. Proper installation of wiring methods is essential for ensuring the safety and reliability of the electrical system. The determination of whether wiring is considered service entrance or feeder is critical for adhering to the National Electrical Code. Service entrance conductors carry power from the utility and are subject to stringent requirements, while feeder conductors distribute power within the building and have their own set of regulations. The fuse disconnect acts as a key demarcation point in this scenario. The 4/0 shielded electrical cable has an ampacity exceeding the load requirements, and if the installation complies with National Electrical Code Chapter 3, conduit protection under Section 230.7 is unnecessary. Consulting with local authorities is recommended for compliance with local code amendments, and it is always best practice to maintain clear communication and documentation during the process.